Welcome to Section 11, Lesson 10. Quadratic inequalities ask which x values make a quadratic positive, negative, or zero. The procedure builds on what we learned for solving quadratic equations. Find the roots first, then test signs. The roots split the real line into intervals where the quadratic has consistent sign. Inside each interval, the quadratic is either entirely positive or entirely negative. Picking one test point per interval reveals which. Reading from the graph is often faster. An upward parabola is positive outside its roots and negative between them. A downward parabola does the opposite, positive between its roots and negative outside. Strict and inclusive inequalities differ at the boundary. Strict less than or greater than excludes the root values. Inclusive less than or equal to or greater than or equal to includes the root values in the solution set. Take x squared minus x minus 6 less than 0. The strict inequality asks where the parabola is below the x-axis. Find the roots by factoring. X squared minus x minus 6 factors as x plus 2 times x minus 3, so the roots are x equals negative 2 and x equals 3. Read the graph. The parabola opens upward and crosses the x-axis at negative 2 and 3. Between those roots, the parabola dips below the axis. Outside them, it rises above. Solution. The inequality is satisfied when x is between negative 2 and 3, exclusive on both ends. Write this as negative 2 less than x less than 3. The interval form is open because the inequality is strict. Example 1. Solve x squared minus 2x minus 8 greater than or equal to 0. The inequality asks where the parabola is at or above the x-axis. Factor x squared minus 2 minus 8 factors as x plus 2 times x minus 4. The roots are x equals negative 2 and x equals 4. Read the graph. The parabola opens upward, dips below between negative 2 and 4, and rises above outside that interval. Solution. Greater than or equal to 0 includes both the roots and the regions outside them. So x less than or equal to negative 2 or x greater than or equal to 4. The inclusive bound includes both endpoints. Example 2. Solve negative x squared plus 4x minus 3 greater than 0. The leading coefficient is negative, so the parabola opens downward. Factor. Pull out a negative 1 times x squared minus 4x plus 3 equals negative 1 times x minus 1 times x minus 3. Roots are x equals 1 and x equals 3. Read the graph. A downward parabola is positive between its roots and negative outside them. The strict inequality asks where it is positive, so we want the open interval between the roots. Solution. 1 less than x less than 3 exclusive on both ends. Always check the sign of the leading coefficient first. The orientation of the parabola decides which side of the roots to take. 3 takeaways for quadratic inequalities. Find the roots before doing anything else. Whether you factor, use the formula, or read off a graph, the roots are the boundaries between intervals of constant sign. They are the only x values where the quadratic equals 0. Use the parabola's orientation to read the sign. Upward parabola is positive outside its roots and negative between them. Downward parabola is positive between its roots and negative outside. Sketch the graph if you cannot picture it. Strict versus inclusive. Strict less than or greater than excludes the boundary x values where the quadratic equals 0. Inclusive less than or equal or greater than or equal includes them. Always check the inequality symbol when writing the solution set.